In this video, I'm going to discuss about an important theorem in probability called Bayes theorem. So the statement of Bayes theorem goes like this. Suppose we have A1, A2, An mutually exclusive and exhaustive events such that probability of Ai is greater than 0 for all values of I starting from 1 to up to etc. n, and then let B be another event with probability of B greater than 0. Then we write probability of AI given B by this formula. So probability of AI given B, that means the event B already happened. Then what is the chance of happening of probability of AI given B? So the formula goes like this. You write P of AI, that means this numerator part, and then you have to reciprocal this value AIB. So if you take reciprocal of this will give you probability of B given AI. Then in the denominator we have to write the total probability. That means what are all the events. For example, here we have A1, A2 up to extra AN. So every event you write the same formula like this. So take this one, replace I by 1. So you get P of A1 times probability of B given A1 plus replace I value by 2, you will get P of A2 times probability of B given A2 plus up to etc. Replace I value by n, you will get probability of An times probability of B given An. So this formula we called Bayes theorem or Bayes formula. Let us discuss some problems based on this theorem. A factory has two machines, 1 and 2. So you can name the event like this. M1 be the event of choosing machine number 1. M2 be the event that the item produced by machine number 2. So there are two machines. Read the next line. Machine 1 produces 30% of items of the output. That means probability of M1, that is probability of machine 1 producing 30%, that means 30 by 100. Machine 2 produces 70%, so you can write probability of M2, that is equal to 70%, which is 70 by 100. Further, 3% of the items produced by machine 1 are defective. So that means what? You already selected machine 1. Out of this we have some defective items. So let me write like this. Probability of D given M1, that is equal to 3%, that is 3 by 100. Okay, 4% produced by machine 2 are defective. That means you already chosen machine 2. Out of machine 2, how many items are defective? So that is given by 4%, which is 4 by 100. Okay, so these are the four important events. Now read the next line. An item is chosen at random and it is found to be defective. So you randomly choose an item. It may come from machine 1 or machine 2, we don't know, but it is a defective item. Read the last line. Find the probability of it was produced by machine 2. So here remember, you have already chosen a defective item. So probability of choosing defective items already happened. Now what is the question? It has to come from machine number 2. So you need to calculate probability of M2 given B. Now apply Bayes theorem, you will get this formula as I explained in the previous slide. So now we have to substitute the values P of M2, probability of D given M2, and then in the denominator the total probability. If I say total probability, you have to write all the possible values. So here we have two machines. So first M1 and M2. So all the values are here, right? So this is P of D given M1, this is P of M1, This is P of M2, this is P of D given M2, everything you substitute here in the respective places. Okay, and if you simplify using calculator, you will get this answer 28 by 37. Okay, let us see one more question. So here they have given M1, M2, M3. So there are three different machines. So how I can name it? I can name it probability of M1, P of M1. And they say 30%. So that means 30 by 100. Then probability of M2, second machine, which, which produce 20% of the item. So that is 20 by 100. And then 50% from M3. So that means P of M3 is equal to 50%, that is 50 by 100. Okay, read the next line. The machines also produce defective bolts 5%, 3%, 2% respectively. That means out of this 30%, machine A produce 5% defective item. So how we can write? This means in this case we have already select machine 1. Out of machine 1, how many defective item? That is probability of D given M1, which is 5 by 100. Similarly, probability of you already selected machine 2. Out of machine 2, how many defective items will come out? Which is 3%. So we have 3 by 100. Similarly, probability of you already chosen machine 3. Out of machine 3, how many defective items? So we have the last value, 2%. That means 2 by 100. Okay, now what is the question? A bolt is drawn at random and it's found to be defective. So now you already choose one defective item. So write the event in the down, because as per the conditional probability, whatever item in the denominator, that has to be happen already. What is the probability that this defective bolt will come from machine 3? So that means you have to write M3 on the top. So how to write Bayes theorem for this? Probability of, write the numerator value times probability of, write the reciprocal, that is D given M3. So this is on the numerator. In the denominator we have to write the total probability. If I say total probability, you have to start from P of M1, then P of D given M1 plus P of M2 plus P of D given M2 plus P of M3 times probability of D given M3. So you have everything is here, right? So all the values are here. So just substitute the value, you will get this final answer. So this one similar model, so I don't want to discuss, do it from yourself. Okay, same idea, M1, M2, M3, 25%, 35%, 40%. So that means P of M1 equal to 25 by 100 or 0.25. P of M2 35%, that is 35 by 100, 0.35. Probability of M3 40%, which is 40 by 100 or 0.40. And then they say these machines produced defective bolts also, 5%, 4%, 2%. So first you write probability of D given M1, probability of D given M2, probability of D given M3. So 5%, 4%, 2%. Now a bolt is chosen and is found to be defective. That means probability of, already you choose defective bolts. What is the probability that this bolt will come from machine number 2? So on the top you write M2. So you need to calculate probability of M2 given D. So by using Bayes theorem, you can write this formula, substitute all these values here. Okay, you will get this as your final answer. One of the two bag is selected at random. So that means we can select either probability of B1 or we can select probability of B2. So since we have two bags, selecting one bag out of two bags is nothing but 1 by 2. Just like selecting a head or tail in a coin. Okay, Read the next line. A ball is drawn from the bag and is found to be red. So that means you already selected the bag, okay, B1, and from B1 how to select R. So in B1 there will be 4 red balls. The total number of balls are 8. So I can say 4C1 divided by 8C1. Similarly, probability of selecting R given B2. So that means you already selected bag 2. Out of bag 2, how we can select a red ball? So we have 2 red balls and 6 black balls. So total number of balls are 8. Out of 8, we select 1 red ball from 2 red balls, 2C1 divide by 8C1. So that is, this is equal to 4 over 8 and this is equal to 2 over 8. Okay, so that is why we have written here. If you simplify, you will get 0.5 and 0.25. Now what is the question? A ball is drawn from the bag and is found to be red. So that means you already know that the ball is red. What is the probability that it is drawn from the first bag? So you need to calculate probability of B1 given R. So once again, by using Bayes theorem, let me write this formula. Then in the formula, if you substitute the respective values, we will get probability of B1 given R as 0.667.